It's great to talk to our customer Specialized. My name is Leo Leung. I'm a Senior Director of Product Management for Oracle Cloud Infrastructure. And it's great to talk to Tommy Pham of Specialized. Good to see you, Tommy.
Good to see you, Leo. Thank you.
Can you tell me a little bit about Specialized and your role there?
Sure. My role as Specialized is to ensure our EBS systems used in 48 countries is available 24/7 for our riders to perform transactions on our B2C and B2B systems. So when it was time to sunset our Oracle superclusters, moving to Oracle Cloud Infrastructure was really an easy decision. Also the OCI project was a massive undertaking that requires a global EBS systems and over 200 plus integration that has to be moved to Oracle Cloud. And my role was to ensure that we make this massive migration without impacting our riders and retailers, and set Specialized for a future in the cloud that provide faster transactions and system, and a 24/7 disaster recovery capability.
Can we let's actually cut over to the first diagram. This is a significant undertaking, as you said, a lot of different services. Can you give us maybe a high-level picture of how the pieces fit EBS as well as some of the other pieces in your architecture?
Yeah, so our primary regions runs out of Phoenix, Arizona. Specialized tenant, we have, if we look from the top down, right, you have public and private subnets where we interface with our third-party vendors, POS system, customers, retailers, other cloud vendors. Those are external facing web services that we transact with. And it's mainly driven by Oracle WebLogic's enterprise, developed, designed in a HA cluster environments. And working below in the middle of this diagram, we have all of our integration internally to support our internal data warehouse, distributions, printings, and internal application with handle our EBS transactions. A lot of interfaces that is required to interact with other services like Agile and custom application database links and so on. This operates on a 2-rack node Exadata database engineer systems. That gives us the high HA cluster capabilities for fault tolerance.
So is it fair to say that when a customer comes to Specialized and orders on your website or goes to one of your stores, this is sort of the infrastructure that's supporting that activity, as well as maybe some of the inventory, and then bringing the actual products to the customer? Yes,
it's fair to say that our web application tier, which mainly run on WebLogic's, with SOA Suite services that deliver the transactional informations to our clients and consumers, and for inventories and order processing. So everything is also retrieved and recorded back into our EBS systems. Also, our B2B portal is also running on our 9IAS application services. And that is really our crown jewel legacy system that servicing our business partners, retailers throughout the world. And that's still one of our key strategic applications.
Great. So one of the things that I understand about your architecture is you have a lot of integration points to, again, different applications, some of your business units, some of the other parts of your business and your partners. Where are those in your architecture?
Those are mainly driven by our global web services, that you can see at the top of the diagrams. Right? Those are all the integration web services are designed, built, and deploy running out of that public service facings. And along with our 9IAS B2B portals. Those are handling our external transaction processing transactions. Our FTP server is also managing for inbound, outbound file transfers to and in and out to our vendors and POS partners.
So some of your partners you have to deal with a variety of different types of interfaces to your partners,
Exactly.
including FTP,
Exactly.
which is our favorite technology.
Yes. Yes.
Um, talk to me a little bit about how you've designed it, from a security perspective and a resiliency perspective. I see a lot of load balancers, both internal and external. Can you talk a little bit about that?
Yeah, it's ideally it hides the complexities and the actual naming host name convention, right? It's also does give us the capability of load balance and round robins around the application tier. When you have multiple application server running, the load balancer gives us that capability to scale and then to hide the complexity behind that, and also for security reasons. And so far, we pretty much use our load balancer throughout most of our application tiers. It's a big plus and big benefit for that.
How about the use of subnets and segmentation in your network? Can you talk a little bit about that?
I think mainly it's really for subnetting different type of applications and transactions, and also it's for breaking down security reason as well. What subnet can interact with with what, more segmentations that allows us to, in terms of managed billability, and we know what application belong to where and how they can be deployed. And also mainly the main thing here is really a security standards that we can lock down which subnet can interface to whom and what.
Okay, and you talked about being able to leverage rack, being able to leverage Exadata. Were those sort of factors in your decision making as well?
Absolutely. We have done a POC prior to cutover, and we've noticed we were getting 4.8 times performance improvement on our online processing, also batch processings. The ability to dynamically upscale our CPU, the core usage when it's needed on demand. The ability to stand up a provision a VMs is within minutes, versus acquiring a separate web server, and we have to stand up and network it and install it. That could take a few days or weeks to stand up one. So this is a huge advantage for us to give us this capabilities to build and deploy and stand up any compute environments, whether that's Windows, Oracle, Linux 5, 6, 7, you name it, it's all there, and it's within the marketplace. So we can just go and grab it and deploy. That's the beauty of it.
That's great. So you talked a little bit about this ability to scale up and down. Can you talk about when you do that? Like what type of scenarios do you employ that?
It's not going to be toward the busy month-end period where we see performance transactions count increased. We see the usage is also raising. So what we do is we say this is the time period that we need to scale up add additional OCPUs for that time period, and we can reduce the count, and that just within a few minutes time to accommodate that change, and so we can scale up, scale down.
That's great. Does the infrastructure also support sort of again peak demand from ordering or again customers coming in the front door?
Yeah, I mean it's really all the processing is really happening at the as the database, the rack clusters is really where all transactions are being committed, and then being the load is taking the most hit. So what we do, we monitor through the Oracle Enterprise Managers, and we look at the usage of each of the rack clusters, and we see where it performs it in, and we can rebalance that. Some of the application server could be hitting too much on the on the primary clusters, and we can rebalance it and point it to the second cluster we might need it. And once they're equally distributed, and then we just pretty much go in the portal, say, hey, we need additional 2 OCPU. Let's spin it up. Once we're done with it, we'll just descale it and just turn it back down to throttle it to the limit it was before. So It's just the ability to do that by flipping a switch is just you can't beat that, right? With the old on-prem system, will take us days. We'll take a downtime to do that.
Thanks so much, Tommy, for sharing your story about how Specialized is using OCI. Thanks for joining us on Built and Deployed. Look forward to the second video about Specialized, where we get a little bit deeper into their architecture. Thanks so much.